All right, we're live. ANZ Coders 2015. So I want to thank everyone for spending an evening with us as we nerd out and geek out amongst whatever we happen to be doing, which is going to be F# to start off with. For those, which is everyone who hasn't been in a session before, the way this will work is, as you probably already picked up, there's a chat room over on the right-hand side. Feel free to jump in and chat there, say hi to everyone else in the session, ask questions of the presenters there. You'll always see on in that Crowdcast app, there's a actual Q&A area as well. Feel free to ask questions in there, and some polls and so forth. For reference, I'm Richard Banks, organising this particular shenanigans. But I'm going to get out of the way because it's not about me, it's about you guys. And this particular session that we're going to start off with, which is going to be by Jorge Fioranelli, he's going to get started in 3, 2, 1. So I'm going to hand over to Jorge. Jorge, it's all yours, mate.
Thank you, Richard. Hi, everybody. My name is Jorge. I am a lead consultant. And so the idea of this session is to inspire you to move to F# by showing you 5 different areas of the language that I hope you find interesting. So if you have any questions, as Richard said during the session, feel free to ask that using the Crowdcast application in the Q&A window that you have there. If I see any questions while I am speaking, I will try to answer that. But if I miss any of them, don't worry, because at the end of the session, I will try to go over all of them and answer as much as I can. Okay, let's start. I am a Redify lead consultant. I also organize the F# Sydney user group, and I often run an F# workshop to introduce F# to developers. And the expression that you see there pretty much reflects my feelings for F#. So if you don't understand how that works, don't worry, I will explain that in a few slides. So the first question is, why F#? Well, if you are already using .NET, in my opinion, F# is the best language that we have available there. So if you feel like you already know everything about C#, it might be a good time to maybe start looking at a new and more advanced language as it is F#. Many of the features that C# is getting over the years are coming from F#. F# is a functional first language, what means that it is functional, but it also allows you to write imperative and object-oriented code. It is full supported in Visual Studio. It has interoperability with other languages like C#, so you could call C# from F#, F# from C#, and you could potentially have both C# and F# projects in the same solution. It's multi-platform, what means that it runs on Mac, Linux, Android, iOS, and all the Windows platforms. It is open source, and obviously Microsoft is one of the main contributors, but it also has a very strong community. And some of the features that are coming in the next version of the language are coming from the community. And in my opinion, it has a great syntax that it might be a bit hard at the beginning, but once you understand it, believe me, there is no way back. It's a very nice syntax that comes from a language called ML. If you want to know more about F#, you could go to that webpage. There is a non-profit organization behind the language. You could join that organization and help to drive the language forward. Okay, let's start with the first reason. And in my opinion, the first reason is the fact that we have powerful functions. As you could imagine, when using functional programming, functions are a very important part of it, the same way that objects are very important when you write object-oriented code. So we don't have a concept of a function in C#. The closest thing are methods or delegates. So what I will do is to copy that method that we have there and start transforming it to F# so you could see the differences. The first thing that I will do is to remove the types from that signature. And this is not because F# is a dynamic language. It's actually strongly typed the same way that C# is, but it has a very powerful type inference system that will infer the types for you most of the time. So what you get as a result is a strongly typed language that looks like a dynamic language. We use camel case as a naming convention for functions. So we will change that. And we don't use parentheses and commas to separate the arguments. We just use spaces. And also what we use is the let keyword to declare a function in that way. So next to the let keyword, you will see the name of the function, and after that, you will see the arguments. We don't use curly braces for functions. As F# is white space significant, we remove that. And we don't need to put semicolons next to each of the lines, so we could remove that as well. Instead of using the var keyword, we need to use the let keyword to define in values. And here you could see that we are using the same keyword for both defining a function and defining a value. And the reason behind that is that functions are treated as values in F#. Also, we don't use the return keyword, as every single line in F# is going to be an expression and is going to return something. The last expression that gets executed inside the function is what that function is going to return. So now we could remove that extra line from there, and we get equivalent code. Something that we could do in the C# side is to remove that intermediate step that we have and just return the sum of those two elements. And the same is true and is something that we could do in F#, removing that. And whenever you have a function that only has one line of code in F#, you could write it as just in one line, in this, like in this example. You will tend to see that you will write a lot less code when writing F#. In this case, it's a bit extreme because it's a demo, but in some cases, you could easily see that your code base gets reduced by half when just you migrate to F#. The method or the type of the method in C# would look like that. It's a func that will have 3 integers, where the first 2 are the input and the last one is the result of that method. Well, the type of that function in F# will also have 3 integers, and also the first 2 are going to be the input, and the last one is going to be the result. To call a function in F#, you just put the name of the function and add parameters next to it using spaces, and you will get the result in that way. But you could potentially remove, for in this example, the last argument, and this in C# will show a compilation error because one of the parameters is missing. While in F#, what you get as a result is another function that is still waits for that last parameter. So instead of calling this result, I could rename it to add1, because now it's a function, and I could call this add1 function with the last parameter and get the result that I expect. So this concept is called partial application, and it's useful in functional programming, especially when you probably don't have all the function. So what you will do is calling some of those arguments, and what you get as a result is another function that remembers those arguments for you. As I mentioned before, you could call that function in that way, but you could also call it in this way. And in that example, what I am using is what is called the pipelining operator. And what that operator does is to take whatever is on the left side and send it as the last argument of that function. So using that operator will allow me to write code in this way. In which I am being very clear and declarative. What I am doing here is taking a customer and sending it to the promote to VIP function, and the result of that is going to be sent to the increased credit function. So again, this concept is called pipelining. And something else that you could also do in F# is to take 2 functions that you already had and glue them together to create another function. In this case, the function add3. So then you could call add3 as it was just a normal function, and you will get the result. This concept is called composition. And another thing that it tends to be useful in F# is when you need to write things like unit tests and you need to separate things with underscores. In C#, well, in F# you could write the name of the function by using double ticks and putting spaces there. So in the case of a unit test, this is how it's going to look in the test explorer. And you could see that it's much clearer in the F# example. Okay, so now that you understood how the pipelining operator works, I guess you could understand this expression. What this is doing is to taking F sharp and sending it as the last part of that expression. So what we get as a result is I love F sharp. Okay, let's start with the second reason now, that is the fact that we have great types in F sharp. And I will show you a few examples of that. So here we have a class in C sharp that is what we will call an immutable class, because once you set the values, there is no way you could change them. And this is something that we use a lot in functional programming. So we will take that class and we will transform it to an F sharp class. So the first thing that we will do is to change class and use, instead of a class keyword, use the type keyword. We remove the curly braces because they are not used for classes. Instead of using a constructor in this way, we will use the primary constructor in F sharp that looks like that. And whenever you use the primary constructor, you don't need to specify a read-only field because the compiler will specify one for you. So we remove that. And the way that you define a read-only property in F sharp is in this way. So again, here you see that the amount of code got reduced quite a lot. And also, to be honest with you, you won't be using classes that much in F sharp. You will potentially use them when you want to expose your code to C sharp. But most of the time, if the code that you are writing is just F sharp, we will tend to use something that is called a record. So the first thing that you see there is a class, while the second thing is a record. Both are reference types, but the main difference is that the records are, they have better support for immutability. They have something that is called structural equality. That means that two customers in this example with the same name will be the same customer, and that's very important from the functional point of view. And also they have better support for type inference. Okay, another type that is used a lot in functional programming is the tuple. And we do have tuples in C sharp. That's the way that they look. But we don't use them that much. So you would use a tuple when you need to return more than one argument from a method. You could also potentially use an output parameter or create your own class. But in this example, we are using a tuple. And I think we don't use that much because we need to access those item 1 and item 2 properties. While in F sharp, what you could do is to decompose that tuple into two different values in the same line, like you see there. So I will get the name and the age in the same line. And this also works when working with output parameters. So in this case, I am calling the try parse, and I am getting the success and the value in the same line as well. If you analyze the signature that you see there, we are getting the customer age by its ID, so the ID of the customer. And what we see there is that the return value is an integer. So whenever I consume this method from C sharp, I could be sure that I will never get null because it's an integer and the compiler will never allow the code to return null when it is returning an integer. If for some reason this method could return a null, then what I need to do is to change that signature and use a nullable integer. And therefore, now I am being explicit about the fact that this is a null, and the caller of that method needs to know, or will know, that needs to handle that case. But when we are talking about reference types, C sharp doesn't do any distinction. We will use the same type customer for both cases, for when the customer could be null or when the customer won't be null. So now the caller needs to guess if maybe it needs to check everywhere if the customer will be null or not, or maybe we do what we tend to do, that is to guess that maybe it's not going to be null, and then in the end we end up having no reference exceptions. So what is missing in C sharp is the concept of a nullable customer that would be used for reference types. As you could imagine, that in F sharp is different. We have the concept of an option that is the equivalent of a nullable, But that also works for reference types. So in the third example that you see there, that is when we return a customer, the compiler will never allow me to return null because I am saying that I will return a customer. In the same way that the C# compiler will never allow me to return nulls when I am returning integers. So this is the main reason why people will say that in F# we don't have null reference exceptions. Another interesting case is the example that you see there on the screen, in which we have two different figures that are expressed, one in meters and the other one in kilometers. And then we add them together, and obviously that will give us a result that doesn't make any sense because they are expressed in different units of measure. But obviously the compiler is not smart enough to understand that we are talking about different units of measure by just reading the names of those values. Well, in F# we have something called units of measure, and that are specific types that we decorate with those attributes. And then what we could do with those types is to attach them to the figures in this way. So if we do that, then if someone tries to add them together, you get a compilation error because they are from different units of measure. And another thing that we use a lot in C#, it's a concept of the anonymous type. The main problem we have with anonymous types in C# is that they are very hard to pass to different methods because the type is defined behind the scenes by the compiler, and there is no easy way to pass it around. While in F# we have something called object expressions, that basically what we do is to create a new instance of that object, but at the same time we implement an interface. So that means that the product there, it's implementing the iProduct, so I could pass it to any other function that expects an iProduct. And if the interface iProduct also defines a method, I could easily implement that method in that way and define inline the behavior that that method should have. Okay, so the third reason was pattern matching. And here we had code, C# code, and we have an enum that has two different values there, and we have a method that will print a happy face or a sad face. And the same code in F# would look like this. The first thing that we will do is to convert this to be a discriminated union that would look like that. And then we convert the function to be like this. So it's the show function, and the switch statement would look like this. We will use the match keyword there. And each of the cases is going to be a different pattern. So what we have there, it's a success pattern. And when that is true, we will execute that line of code, the console write line. And when the error pattern is true, then we will print the sad face. But in F# we tend to use, instead of the console write line, although you could use that, we tend to use the printfn function in this way. That is a bit shorter and it's a bit different as well. So at this point in time, we have equivalent code, and we could call it in this way, and we will get the happy face or the sad face. So something that we could do in F# now is to take advantage of the fact that we are using discriminated unions and add types to those items. So here we could see that the type success is of type integer, while the type error is of type string. And to do something like that in C#, you will need to create your own hierarchy of classes, and therefore the switch case statement won't work anymore. While in F# you could add just a value name to each of the cases, and then you will capture there the value. So in the case of the success and the error, we will have the integer on the R and the message on the M, and then we could use that on the right side when we use the printfn. And notice that for printfn, you need to use this pattern of percentage and the type. In the case of the integer is %i. And in the case of the string is %s. So you could call this now in this way, and we use parentheses to encapsulate the argument, and we get a happy face with the number 2 and the sad face with the error message. And we could even extend that a bit more by using any type type that we were. For example, in the case of the success here, now I have two integers as if it was a division result. And in the case of the error, I am using a type of exception, but you could use any type that you want, even your own types here. And you change your patterns side by taking into account those different, so you decompose the values there, and in the case of the success, you have the Q and R with the values, and in the case of the error, we have an exception, so now we use a message of that exception. Okay, so something else that we could do now is to start adding more patterns. In this case, they should be more specific. So I will create a new pattern here at the beginning that will be matching the case of the reminder being 0 and Q being more than 1. And in that case, I will print another message. So when you call it, you could call it in this way, and you will get the 3 different messages there. And in some cases, you might find that the patterns start becoming quite complex, and you want to put a name to them and maybe to reuse them in other parts of your applications. So there is a feature called active patterns in F# that allows you to do that. So here we see that we created a new function that is called pieces, and that's is using those characters to specify that as an active pattern, but then I could reuse it as part of a patterns in my function. Okay, that was the third reason, and now we will see the fourth one, that is type providers. So type providers are giving us types for us. So imagine we have F# on one side and we have a data on the other side. And that data could come from different sources, could be on the cloud, in the database, and files. And that data will also come in different formats, potentially. But from the F# point of view, we only care about types. So what type providers do is to generate types for us, inferring the types from those sources of data. So let me show you what I mean by showing you an example. Here we have in the first line, I am using the CSV type provider, and I provide a path to a file that will have a sample of the schema that I will use. And what I get as a result is an actual type. So notice that I am not using the let keyword. I am using the type keyword because this is going to be a type. And then I could use that type. It will have a method called load, and I could put a path to a real file that will have all the information that I will specify in runtime. But the interesting part is that now when I am writing the code, I already have access to the different properties that the customer will have that were inferred from that file. So in this case, I will have access to name and credit with the specific types that were inferred. Another example could be the entity framework provider, that I actually need to provide a connection to a local database. And while I am writing code, it will access that database, and it will give me access to all the tables and columns that those tables have inside that database. So I showed you an example with the CSV type provider and the entity framework one, but there are plenty of other type providers. Here you have a list that is not complete. So anytime you are using F# and you need to access a source of data, maybe it's worth checking if there is no already type provider for you. Okay, that was the reason number 4. And the last one is going to be computation expressions. So this is a pretty advanced feature. I will try to simplify the feature here so it's easy to understand. What we have here is a code that in the first line we are evaluating if 1 is even, that is going to be false. Then the second line we are evaluating if 2 is even, that's going to be true, and the last one is going to be false because of the first one. So the idea here is that I want to get as a result, I want to print on the screen the values for each of these the result for each line. So in the first case, I want to get false. When the second line gets executed, I want to print true, and in the last line, I want to print false. If I want to do something like that in C#, I will need to add console.writeLine after each line. While in F#, something that you could do is to take advantage of a feature called Computation Expression. And here I am creating a computation expression called log, that it doesn't exist in F#, and at this point in time it won't compile because it's something that I am creating. But notice as well that I am wrapping all the code using curly braces, and I also I changed it slightly by using let exclamation mark or let bank for each of the lines, and then I am using the return keyword at the end. So the next step is to create what is called a builder. That is what is going to handle that computation expression. So what I get here, I am creating a type that has a bind method and it has a return method. And also I create an instance of that type. Notice that in F#, when you create an instance, there is no need to use the new keyword. So we create an instance just straight away. And that name has the same name as I am using in the computation expression. So then what is going to happen now is that when the first line gets executed, then the bind method is going to be executed, and I get the opportunity to print the value for that X value. And when the second line gets executed, then the bind method is going to be executed again, and then I will print the value for Y. And when the return line gets executed, then the method return is going to be executed, and I will print that result. So as I mentioned before, computational expressions are very powerful. And what I am showing here is a silly example. We don't use it this way in F#. And this is a concept that used a lot in functional programming. But I want to show you a few of other examples so you could see how you could use it in a real application. So here we have a function called read that will read all the content from a file, and it will print it on the screen. If you want to convert this to be async, in F#, instead of having the async keyword as part of the compiler that will generate an state machine for you behind the scenes, we use computation expressions for that. So we change this code and we use the async computation expression, and notice that I am using the let bank keyword the same way that you will use the await keyword in C#. Another example is the query computation expression that the entity framework type provider has. So we use that query expression, and notice that they have implemented their own DSL inside that expression that allows them to put keywords there. And the last example that I wanted to show you is the one from a framework that is called Embrace, and they use a cloud computation expression. And the idea behind that is that each of those expressions are going to be executed in different machines. So the first one is going to be executed in one machine, the second one in a different machine, and the third one in another machine, and it will take the results from the other two machines. Okay, so that's pretty much all. To recap, we saw powerful functions, and there we saw concepts like partial application, pipelining, composition, and being able to create functions that have spaces inside the names. We saw also great types, and there we saw how to create classes, records, tuples, option types. We also saw units of measure, and the fact that you could create object expressions that implement interfaces. In the pattern matching reason, we saw how you create discriminated unions, and also how you could encapsulate patterns using active patterns. For type providers, I showed you an example for the CSV type provider and also for the entity framework type provider. And in the last one, you saw a very simple example of a log computation expression, and then a few other examples in which you saw the async one and the entity framework, and at the end, the cloud expression. So that's pretty much all from my side. There you have my details, the slides, and the code samples for this presentation are in my GitHub account in that URL. And you have here a bunch of resources that I think are pretty cool for learning F#. So let me see if we have any questions.
Let's do 2 questions, and then we'll have to switch sessions.
Yeah.
Nice recovery, Georgia. Nice recovery.
So let me see the questions.
Right, so there's one here that's, in what situation would you recommend F# over C#?
Okay, so that's an interesting question. What I would say is that in most of the cases, so if I show you, maybe I have one slide here, that is this one. So if you see, C# is an imperative language and F# is a functional language, but both are multi-paradigm. So you could, C# will have some functional features like link, and F# has imperative features as well. So most of the problems that we solve every day could be solved with any of these languages. It's just a matter of taste. If you want to approach a problem from an imperative point of view or from a functional point of view. And obviously, there are cases in which there are some problems that are easily solved with one mindset and problems that are easily solved with other one. So for starting, I would say that any type of calculations are going to be a better fit for functional code, but that's not the limit. So that would be the first case for you to start using F#. But then once you get more used to F# and functional programming, you will find that you could easily write the same code or solve the same problems that you solve with imperative code, but using functional.
Cool, and let's very quickly just do the other one that says, is Redify actively using F# for any live projects?
Yeah, we do have a few projects in different states in which we use F#. Yeah, we do.
And there we go, all right.
Yeah.
So we are done in terms of time. We've got a 4-minute changeover for the next session.
Okay.
George, thank you very much. We're going to do the big round of applause, but it's virtual, so we have to do it without making any noise. Sorry, bad joke. Really appreciate your time, George, and for the audience, thank you as well for jumping in and bearing with us through the pause.
Yes, sorry about that.
All right, we're going to do a quick switch of sessions. So this session is going to go offline briefly. What will happen is I'll end up calling you into the next session. So you'll get that invite, and then what you'll find is that the browser window you're in should automatically kick you across to the other window. So we will see you on the flip side.
Thank you.